Okay, so we will get started from the very scratch. I have not seen the data yet. I have just downloaded the data and I have just opened the Google Colab and I want to give, so technically this particular workshop is mainly for those people who are just getting started. So anyone who has already done the pre-processing or those things, they will know more than what I'm going to tell you. But yes, I will be talking about different ways and how exactly I research. So I'm showing you, for example, an unseen data. So I haven't seen the data. I just downloaded the data and I haven't taken a look at it yet. I haven't taken a look at your notebooks yet. So which means if I'm starting from the scratch, I would be doing some troubleshooting. Yes, some things will not work the first time, and that will happen with you as well. So I want to give you a first-hand look how means any person should approach this particular thing. Okay. So, and if you have any questions in between, just raise your hand, because if I'm talking about something, just raise your hand, and anybody can raise their hands by using the reactions button on their screen. If you press the reaction button, it gives you several different emojis and a raise hand button. So just press that raise hand button. I would be able to see that you have a question. And once I'm done explaining whatever I'm explaining, I will ask you, I will come back to you and I will listen to your question and I would be able to answer your question. Sounds good? So, feel free to, whenever you have a question, and keep one thing in mind, there is no silly question. Ask me any question. If I'm able to answer it, amazing. If I'm not, I will search it in front of you on Google and I will show you how to do research, because majority of this data science thing is Googling, and how to Google things is something which I would be showing to you. Okay. So let me share my screen. So first thing first, I will share the one. Okay, so let's hide these. Okay, so first thing first, I have already opened. So this is one of the template file that I have. Just a second. So I have a template. So this template is what I used in Omdena's Philadelphia chapter. And you can use that chapter as well. What I have done so far, you can see the data over here is still the Omdena Philadelphia's data. I'm going to change some things in it because you can use same template over and over again. You don't need to write the whole code all over again. If you have a very good working template, I would recommend you just keep that template and always start with that template. And that is what I'm going to do. So first thing first, a few libraries that we are going to use. The first one is I would be using this missing no or missing null values library, because this library is an amazing way to check or take a sneak peek where exactly in your columns the values are missing. Let me give you an example. So for example, if you look, so this is not our data for now. Okay, I'm just giving you. So this is one of the graph or one of the output from one of the missing no value library. And you can see these are the columns which have missing values, and you can see whether which values, so on what days or what level the values are missing. And based on that, you can see that there are similarities between this particular column, direction underscore max wind, direction underscore peak wind, and max wind. So you can see that the values for all these three are missing at the same level every single time, which means there must be a link between them. So this library is amazing. You don't need to install this library. You can use simple matplotlib to get the results, but you need to write a bit lengthier code. Over here, you are just importing the missing no library and you are writing one line and then showing. If you don't even do that, that means it's technically one line that you are writing and you are getting this result. But if you use the matplotlib, then you would have to write several different things. First of all, you need to display means you need to display a heat map or things like that. So that heat map is going to show you some things like that. So which means over here, I'm saving a lot of time. If you know several different libraries, that's amazing. If you don't know, Matplotlib can do your job any day. So because Matplotlib, all those libraries like Seaborn, all those libraries that you see, they are built on top of Matplotlib. And that is the reason why in all of those libraries, at the end, they ask you to write plt.show, because if you don't write it, it's going to throw in some sort of an line which says that x by x or something like that. If you don't want that line, then you are fine, because on these notebooks, you can render these things right away. But if you don't write plt.show on, for example, like if you're using PyCharm or something, it's not going to show the graph to you. So the output is not going to be visible to you. If you want it to show, you need to write this. So that is a good practice to start writing this, even if you are using the notebooks, because when you get to the production level code or something like that, you would be using a different IDE, and you should be able to get the results over there as well. Okay. So what I'm going to do is I have, so install the missing no library. Anyone who is a beginner who is using, so I'm using Google Colab. I have Anaconda, means I can use Anaconda and Jupyter Lab on it, but I'm not using it. I'm doing this whole thing as keeping beginners in the mind. So which means, let's say you don't have to install anything whatsoever on your computer in order to get started with this data science or with this particular project. What you can do is you have a Gmail account. If you have a Gmail account, you just go and search simply Colab. When you search Colab, it's going to take you to Google Colab, and that's where you are. And here you can start with simple, means it shows you getting started or things like that. You can upload some notebooks, you can grab it from GitHub, you can grab it from Google Drive, or if you want to just take a look at few examples, you can take a look at few examples here. Okay, so what I have done is I have kind of like created a template very similar. So technically I have grabbed it from the Philadelphia's chapter, this one. This is the one I created for Philadelphia chapter, and I would be using the same template for this particular project as well. You must have seen something like this in one of the file Rich uploaded, and technically this is the template that we created together, and we kind of like stick with this particular template in that particular fashion. Now, what are the standard steps? How to get started? Okay, before we do that, first thing we do is data cleaning is the most important thing. But when you go and look in the books, when you read different articles, blog articles, or listen to different people, they talk about different things like exploratory data analysis, data pre-processing, dimensionality reduction, feature engineering, feature selection, those kind of things. A lot of those things overlap on top of each other. It's very hard to differentiate what comes in data pre-processing, what comes in EDA, what comes in feature engineering, or things like that, because a lot of things are repeated in those particular sections. So what we are going to do is we will say that the cleaning the data. So first you get a data, raw data, and when you clean it means get rid of or fix all the missing values, fix all the values which were in a different format, change their formats, and look at their distributions and things like that. So what we are going to do is our goal here is at this step is to get the data tidy, just clean it. Fix missing values, check for outliers, encoding the categorical variables, and some sort of feature selection. For now, we are not doing that. You can do that, but we will move this feature selection part to feature engineering section. And for now, we will be just doing these things. Let's see how far we can go today, and then we will decide what we can do. So first thing first, EDA, this is the process which we will end up in the next step. So right now, this is our first workshop. So I'm starting from the scratch. You need to get the data insight first. What are the standard steps of getting the data insight? First thing you need to do is check out the head and tail of the data. Second step is study and understand every feature. So you have a list of features, and I think Rich has provided you a complete description of every feature. Don't just stick to that glossary or description of those features. You can research about it, because once you understand what every feature means, that means how to handle that feature is an important thing, because understanding what kind of a variable that particular column possess. Is it an ordinal variable, or is it a nominal, or what kind of a variable it is? So based on that, you can determine how to fix that column. Means you need to determine your strategy, that whether you need to apply one-hot encoding, ordinal encoding, or what kind of encoding you need, or things like that. Then you check for the data types. Data types are most important, because they tell you what kind of, whether you have categorical variable or whether you have a numerical variable. And if it is numerical, then whether it is in integer form or float form. Keep one thing in mind. Floats take more space, integers take less space, but some of the variables needs to be integer. For example, like I cannot have decimal numbers. For example, if I am counting number of person in a locality, those number of person should be a real number, not a real number. It should be an integer. That means it can either be 10 people or 11 people. We cannot have 10.5 people. That means decimal values are not ideal in that scenario. So for those variable types, I would recommend, or you would be going for integer, because integer take less space in the memory. That means processing would be faster. But if they have some decimal values, like the area of the surface or things like that, those can be in decimal, which means you need to go with the float. Now, float are of different sizes. Float 64, float 32, float 16. That means how many bytes it is taking, bits or bytes or whatever that is. So how many memory space they are taking. The bigger the value, that means more space they take. So we need to be careful about, when we have big data, we need to be careful about what kind of variables and what variable types we are using. Then look at the summary statistics. It's pretty straightforward. Okay, so we are going to do that and visually look at the distribution. So these are the standard steps of pre-processing. That means it is the data insight. First, you get the data insight. Based on that, then you apply the encoding techniques and things like that, and imputation techniques. So first thing first, I'm going to import all the libraries. For now, you don't need to worry about all these libraries. I'm going to just comment them out. Okay. So what I'm doing is I'm just importing NumPy and pandas. Our data set is pretty big. And some of you struggled with uploading the big CSV files using pandas. So here I'm going to show you how to use pandas to extract big size CSV files. So there is some parameters inside pd.read_CSV, or if you are using the Parquet format. So I'm using the CSV format. I have uploaded the CSV files here, both of them. So I'm going to show you how you can use CSV files still, and it's not going to throw in the read or memory error. Okay, so we are going to do that. First thing first, if I try over here, you can say, I would say it is accident_data frame. So this is my accident data frame. In this accident data frame, what I'm doing. So let me import these. So what I'm going to do, I will call accident_data.csv. If I do this, accident_data frame. If I run it, it's going to take some time, and it's going to be very. So it is picking up 5 rows and 34 columns. Okay, accident data is pretty kind of like small. Is that right? But I don't think it has this many values or things like that. So did you guys so here printing the head. So I'm printing just the head. If I don't print the head, for example, and if I want to check the shape of this particular compound, I can not the compound, the data frame, I can check the data frame's shape. So what I can do is I can come here and I can do so. So instead, so accident underscore df, and I'm going to do the shape of it. So which means I will do this. Technically, let's copy this. And we are going to be able to. So let's look at the shapes here. So what I'm going to do is I'm going to change the name, accident underscore data frame. And I'm going to copy this, I'm going to paste it. So for now, we don't have this, so I can just delete that. So if I do this, you can see what kind of a shape I'm getting. So you can see it is taking a lot of time. Okay. So it is taking a lot of time. I have this many rows in train are this, and number of columns in train are 34. So 101,048,575. Keep one thing in mind. I'm using Google Colab. So Google Colab have some big RAM available or things like that. So maybe that is the reason why it is able to read. But what if you are not able to read these things? Then what you can do is, you never know, you can search for it. For example, I can search for pandas read underscore CSV, read the documentation. Reading the documentation is the important part that you should be familiar with. So this is pandas.read underscore CSV. What kind of parameters it takes? You can see there are a bunch of them, a lot of them, which means whatever problem you are coming across using pandas read underscore CSV, somebody must have come across that, and they must have contributed in the open source program, and they must have updated this thing, which means most probably instead of looking somewhere else, try to go in the first basic documentation and see if you can find the solution. So over here, you can see there are so many things, so many parameters that we can put in. Right now, I'm just putting in filter a file path or something, means I'm just giving the file path and it is picking up the CSV file. I can do so many different things. If there are different delimiters used, I can use them and things like if I want to skip some rows, I can do that. If I want to skip the headers or footers, I can do that. This is footers. So do you want to display true values or something like that? You can do that. You want to change the names or add some prefix on the columns, you can do that. Okay, so there are so many different things. The one thing that I need to mention is this chunk size. When you have a very big data size, you can use this chunk size. What this chunk size do is, for example, we have million rows. For example, your computer is throwing in some memory error. What you can do is, instead of calling all of them at once, you can determine a chunk size equals to, let's say, 100,000 rows. So and then you can run a for loop for that. How to do that? If you don't know, just search for it. So what I'm going to do is I will simply search for it. So how to use chunk size in pandas. Okay, so I'm going to use chunk size in pandas. When you do that, it can take you to several different things. Maybe I'll go to Stack Overflow first. So in fact, I would use read underscore CSV specifically. So this is what it is getting me to. So how do I read a large CSV file with pandas? I can search for it. And when you search for it, people have given different so you have the for loop already given to you. You don't need to write your own for loop. Just copy and paste it and change your variable names and you have a working. So what it does is basically whatever chunk size you determine in the pd.read underscore CSV. So here, this is my file name, which I'm already providing for me. And then I'm determining the chunk size. The chunk size can be anything. You don't need to write this formula or whatever. You can just write 100,000 or maybe 50,000. And when I'm running this for loop means it's gonna go and pick up 50 or 5,000 values or 50,000 values then it's going to go and pick up next 50,000, then it's going to go and pick up next 50,000. This way, your memory error is not going to be happening. Why? Because now it is only picking a chunk out of the whole data at once. So it picks up. So yes, it will take some time, but it will be able to read all of your CSV file, and it's not going to throw, because what happens when you have a very, very large data set and it is bigger than the size of your RAM. So technically, the data that you have should be smaller than the size of your RAM. Because if it is bigger than the size of your RAM, it cannot fit in your RAM, because it needs to come into your RAM and then read. So if your RAM is not that big, then I would recommend you to use this chunk size method, and you can use a for loop over here, and for loop is going to pick up values until it has picked all the values. So I can run it for however many chunks or something. Means if I want to 5 chunks or 10 chunks or something, I can do that. Okay. Now, this was pandas, but now let's read other people's ideas. Now here people are using amazing things. So you can see they're using Dask as well. They're recommending Dask. So just like pandas, there is another data handling library. We call it Dask. So Dask works on parallel computing. So pandas does not work on parallel computing, which means it runs parallel chunks. So just like what you were doing chunk size, but Dask automatically does that for you. So that chunk size thing automatically is happening in Dask, which means if you use Dask instead of pandas to read your data frames, it's gonna do the parallel processing automatically for you. How to do it? The code is already given here. You can see the data frames implement pandas. So this is dask.dataframe as DD. First of all, they imported it. Keep one thing in mind. You need to install Dask first. So what you can do is you can go to your collaboratory. Here we are. And you can come here and you can pip install it. So what I can do is I can do the pip installing. So I can do, so how to do it? Put an exclamation mark in Google Colab and simply do pip install Dask. And it's going to install the Dask. So if it already has it, it's going to tell you requirement already satisfied, because Google Colab has a lot of these things already built into it. Okay. So which means over here, if I want to implement Dask, I can do that. So let's try with Dask. Okay. So what I'm going to do, I will just copy paste this and I will go back here. Where was I? Here. And I will try to read it using Dask. So what I'm going to do, I will just add a code here, and I would do import dask.dataframe as DD, and then dd.read_CSV. And here I'm going to give the path of the CSV. So what is my CSV? accident_data.csv. So, and then I can write df dot maybe head. So you can read the data using this as well. Now some error is being thrown up. Let's read the error. Okay. So to call read_CSV reader, alternatively provide assume missing is equals to true to interpret all the unspecified integers. So what it is doing, usually this is due to Dask D-type inference failing. Now, the best thing about pandas is when you use pandas, you don't need to tell pandas what is the data type of every single column and how to determine it. Pandas does that for you automatically, but Dask is not doing that. And that is the reason why Dask is throwing in errors. So which means it is telling us to add some more parameters. For example, like over here, they are telling us usually this is due to Dask data type inference failing. So it is not able to infer what kind of a data type it is. So it is giving us some sort of scenario that first row, this is float 64, and so on, to call to read underscore CSV or read to. Alternatively, provide assume underscore missing is equals to true. So when you do that, it should be able to work. So I'm going to do that. I'm going to copy this. Sometimes it will give you the answer that what should you try, and sometimes you have to go and search for it. If I do this, and let's try again. So you can see it was able to read it, and you can use Dask as well. Now, there are several different tools. If I start explaining all those, for example, this is a very good one. So here they are also using another important library, just like Pandas and Dask, a data table. If you have used R programming, or if you have done R programming, data table is just like R's data table. So if you are not familiar with it, forget about it, but it works exactly the same way as this Dask did and as Pandas read underscore CSV did. Okay. So which means you have several different tools. And the best part about this data table and this Dask is they work on parallel computing. Parallel computing means wherever Pandas is throwing in error, out of memory error, these are not going to throw in memory errors. And then there is a library which is used more than these is PySpark. So Spark is something which is parallel computing, and there are so many libraries, but if you just keep on talking about which library to use, there are hundreds of them. I'm just showing you some of them that you should be familiar with, and I'm showed you how I'm getting to these particular libraries. I'm searching everything in front of you, right in front of you, what exactly I'm typing and everything. It's on, it's with you. Okay, everyone is good so far? So if you're good, just press a thumbs up on the reactions tab, and that would be amazing. Any questions, anyone so far? Are we good? Yep. Thank you, everyone. Okay. So what? Yes, Dunya, please go ahead.
Hi everyone. I would like to make sure about something. I would like to know if PySpark is convenient at this stage.
Yes, it is. You can use it in place of pandas whenever you want.
Is it good without without cons?
Sorry.
I would like to know. I would like to have an idea about the pros and cons of PySpark.
So pros and cons of PySpark, I would have to Google it, because yes, there are parallel computing. So in fact, I made a LinkedIn post about comparing all these. You can check that out. Maybe I can just find it.
Okay.
So, okay, so okay, so sorry, my bad. What I'm going to do is okay, so okay, let me open it up. So I have made a post about it, and you can read it, and which kind of like summarizes all these four different libraries I just talked about. Okay, where is it? Let's find it. Okay, so Okay, so yep, this is the one. I can show it to you. Let me resume the share. So this is one of the LinkedIn post I wrote, handling large data sets in Python, where I'm discussing pandas, what exactly it does and everything. Then Dask, I'm talking about it. Then data table and PySpark as well. So you can read about it, and then I would recommend you to search about more pros and cons on Google, because on the top of my head, because I use majority of the time Spark. Yes, I have used it, but if I don't need to, I don't use it. So it's as simple, because pandas is my go-to. So I always start with pandas. If pandas is working fine, I don't bother going to any other one. But if pandas is giving me some trouble, then I go to Dask or things like that. Okay. So if I don't know anything, I will just go and Google it. So if you want to pros and cons of PySpark, you can search about it. So these are a few. So simple to write, framework handle errors, algorithms, libraries, or whatever. You can just click on it and you can read about it. Sounds good? So
Okay, thanks.
you still have any question, Dunia?
No, for the moment, no.
So your hand was raised. Okay, so I think the meeting is about, so there is a file size to have in mind to start using PySpark instead of pandas. So Joel, I always start with pandas. I don't. So keep one thing in mind. File size should be in your mind, because CSV files are usually not that big. They can fit in your memory. So majority of the time, these files would not throw in a lot of errors if you don't have big enough RAM. So my RAM on my computer is about 12 GB. So which means for me, I never came across any CSV file that can give me that kind of a trouble, the out of memory error. But when you go to industry or something, if you are using their data, they have billions of data points and things like that. That becomes, those CSV files are huge, and that's where the problems come into play, and you cannot read. Then pandas, then that's where Dask and PySpark or all those different libraries come into play. So keep one thing in mind: if your file size is smaller than your RAM, you should be able to use pandas. And even if it is big, you can still use pandas with some tweaking and everything. But then there are means, why do that tweaking as if you can just use Spark, which is pretty straightforward, just like pandas. Okay. So PySpark is used with big data. So when we use it for small data, means we are unnecessarily installing bigger libraries. Absolutely right, Mukesh. That is the right answer. So it's faster than pandas. Yes, parallel computing is happening, so it is faster. So with Dask, you have to specify the data types, but pandas does it for you. Absolutely right. And please, which difference between Dask and pandas got lost? So Dask and pandas are both exactly the same tools. Whatever panda is doing, Dask can do that. The only thing is Dask work on parallel computing, which means it can use parallel cores of your computer to fasten the process of reading the things. And the chunk size thing, which we were introducing pandas separately, it automatically does that. You don't need to specify the chunk size. It automatically gets the read the data in chunk forms. So those are a few differences. Ataliba, you have any question?
Yes, Salman. I just wanted this template you are using, in case if we have, just to go on, can it be for structured and unstructured data or just for structured data? I'm just trying to.
That again. So you're asking about can we use this template for structured or unstructured data?
Yeah, some sort of it, yeah.
So so this one, you can use it for this kind of a tabular data. If you have, as long as you have a tabular data like that, you should be able to use it. Even if it is structured or unstructured, it doesn't matter, because the steps for whatever kind of a data you have, because I'm not doing any modeling here, which means I don't need to have my X or Y variables or whatever. As long as I have a tabular data, you can use this template.
Okay, I got it. Thank you.
Yeah. So Yes, Hassan.
Hello everyone. Okay, first of all, thank you so much. Actually, whenever we supposed to start a data science project, we need to think about it. What are
Wait a minute. Hassan, wait a minute. Our meeting is about to over. Let's join the meeting again. Okay. So, yes, Hassan, you were asking me a question, please.
Okay, Mr. Salman,
Mhm.
thank you so much. Actually, I was just asking, whenever we start a data science and machine learning and AI project, first we need to think about what is actually trying to do. What is our ultimate goal we are trying to implement on that. If you can mention that what are exactly we are doing, I mean to say the feature we are focusing on. Once we have to specify those features, we need to think about those features and eliminate those features which is not necessary for our project. It will be necessary for the developers and the coding perspectives. It much given a chance to eliminate the memory size, etc.
Yep, that's right. So so right now I haven't taken a look. So I'm assuming that I just got the data first. So which means I don't know what's inside it. So so which means first thing is just take a sneak peek into the data. Once you take a sneak peek, then we will go back to the glossary, the description of every single parameter that we have. And then we are going to start studying about those parameters. Does this parameter make sense, or it is just, for example, like if I one of the parameter is just the index number. I don't care about the index number. It is just one extra column added, which is just telling me that it is row number 1, row number 2, row number 3. That's a waste of memory. So you are right. So which means right now, what I'm doing is I haven't taken a look. So this is the first time I'm taking a look at this data set with you guys. So which means I'm just as blind as anybody can be when they get the data first. So which means I'm doing everything that I usually do in my projects. So I start with, because I don't know what variables it has. Yes, I have been looking at the meetings and I have been listening to presentations of everything, but on my own, I haven't taken a look at the data myself yet. And I'm not utilizing all those insights that everybody gathered. I'm kind of like breaking it down using beginners in mind, so that anybody who is starting to get into this, they don't feel overwhelmed with a lot of different things that a lot of leads are talking about. Because yes, the leads who are doing a good job, co-leads, they have some sort of experience in that. Some of them are very proficient, and some of them are still means they are proficient and they are comparatively. So there are some differences, but still they have some kind of head start. So those beginners, how to address their issues, my goal is technically this. So I'm taking a sneak peek just like anybody does when they are starting the data set. So I need to take a look at what data set I have, what variables, what data types, how many missing values, and then I will go back and read the glossary, the description of the variables, all the parameters, and then we will determine and read about it. So we will do that. Does that answer your question?
Exactly. Actually, I'm the same conditions, just like you. You cannot look at the features and the actual planning and strategies of the implementation of this project. It is exactly whenever you implement the data science projects, it is completely coding is not difficult in AI.
Yeah.
Just the strategy and planning is you must have to a good strategy and policies. What are you doing to try to implement this project? If I'm not wrong, we are trying to implement road traffic collisions predictions using machine learning. So I think we need to focus on the features and the planning and strategies of that. Data is although big. Data is big. Data comes from the different resources. Maybe it's when sensing. Maybe in the future, maybe it will be in images. Maybe in anyhow. But we need to whenever the data is too much big, it consumes RAMs, memories, etc. And we have not of resources to take all this data. So what we are trying to do, if we can implement somehow with the visualizations and tabular, etc., to look to the data, that's what are the features, what are the key values that we need to focus on. And if we are in an example, I can say about it, what are the date on this particular road size, the collision takes mostly, then we need to the points to be there. So okay, coding is not difficult in in AI. Just we if you have good plannings, then we move forward in deciding maybe you can use pandas, make you maybe we can task, etc., and so on. Thank you so much.
Oh, thank you so much for sharing your experience. That's really amazing. So yes, that's right. You can see so far what kind of coding I have done. I'm copy pasting things, and that is what every data scientist do. Every programmer do, because somebody must have done that. So you just grab their code and change your variable names and your things, and you have a working code. So you would see that I'm doing code along. So I'm talking about code along, and I want to show a lot of people kind of like are they are kind of like scared that if they show that they are copy pasting stuff, that is wrong. No, I'm just giving you a first-hand look what I do. So I copy paste stuff from Stack Overflow, from Google, from my own templates and things like that. And those templates I have kind of like built by doing a lot of experiments. And after doing those experiments, I realized these steps are pretty much same. Then why not just make a template out of it so that I can just always start with that template and change the variable names, and I'm done. So that is what you will learn, that coding is not the big deal. Understanding what we are doing, how we are doing, and how we can change is basically what Hassan was trying to say. So yeah, thank you, Hassan, for sharing that. So we are going to get back to our coding thing. Okay, so let me hide these floating things. Okay, so here we are. First thing we did is we read the data. I showed you how to read it with pandas. And if you want, you can use, means I showed you how to search about how to use chunk size or something. You just copy paste this chunk and it's gonna read your CSV file, whatever. So you can do that, okay? But since I have already read it, I just wanted to show it to you that how to search. So I have you already used Dask, means you can just use Dask as well, and it's gonna give you the same thing. So now that is the first step, reading this CSV files. Once you read the CSV file, we don't have the test file, so I'm going to delete it. So, okay, why is it not deleting? Okay, so looking at the shape, we have already taken a look at the shape. So what I'm going to do is I'm going to comment this one out. So we don't have a testing shape, so we have simple. So I would keep on using this accident_df instead of this df. Okay. Now we have taken a look at the shape already here. So I'm gonna skip this whole thing, and I'm gonna comment it out. So next thing, let's take a look at the info. Info tells you what kind of data types every column has and how many values. So you can see you will be getting something like this. It's going to tell you how many non-null values it has and what are the data types. So which is a very good thing to do, because this way you will understand what kind of whether these are object data files, whether these are integers. So you can see integer 64, object are the categorical variables most probably, or string variables. So float and then integer. So you can see all these things. So let's try with our data set. So I'm going to do accident_data. And so let's do the info of it. So did I do something wrong? Let's see. I think my spelling is wrong. Accident_data is not defined. Sorry, df. My bad. So it is df, and let's run it. So when you run it, you can see, now you can see, remember how many variables did we have over here? So we had kind of like this kind of a shape. So I'm gonna just cut it, and I'm gonna paste it here so that I can keep tab of it. So we have 1048575 values. Anyone which does not have that many values, which means it has. So this one has missing values. This one has missing values. This one has very few missing values. All of these have all of those values. You can see some of the numbers over here a bit different. That means very few values we can get rid of them with. And because that's not even 1%, I can see. So this one has a missing value. So we can do that. Yes, Kevin?
Yeah, just quickly with the float 64 and 32 and 128 and whatnot. When would we not use 64?
So majority of the time. So that is where the memory size comes into play. Float 64 and 128. You can see the number is telling you how many bytes or bits. I'm always confused about it. It's going to take to save that particular value. So bigger number float 128, that means more space, which means if you have a lot of data, then using smaller float 32 would be ideal. So right now we are using simple basic machine learning. When you get to use deep learning or something, that's where memory would be pretty important thing to handle. For example, like TensorFlow uses all its processing. It is being done on float 32 size, but NumPy always converted into float 64. So whenever you are using for deep learning things, what you do is you basically, if you are using NumPy to read your data, then you need to change the data type from float 64 to 32. For that, you can read it in TensorFlow. Otherwise, TensorFlow is not going to be able to read it. So these are memory sizes, memory allocations, and you should be smart about it. And if you can use smaller memory size, that is ideal. So majority of the time, these tabular data set that we are practicing with, this is not industry data, which means industry data is in terabytes, in GBs. Which means that can be messy, and that's where these things you should be worried about. But for now, whatever it is, you just stick with that. The only thing is integer and float 64. Integer takes less memory, float takes more. So if one variable you think does not require decimal values, for example, like year 1, year 2, year 3, year 4, we cannot have year 1.5 or something. Means we can have 1996, we can have 1997. We cannot have 1997.5. So those kind of variables should be integer, not float, because I'm just wasting my memory.
Yeah.
So, yeah. Is that
cool? Thank you. Yep. Thank you.
Mm-hmm. So, okay. So what I was talking about is, you can see I'm looking at here, yes, null values and everything, but now at the bottom, you can see when you do this info thing, it's going to tell you what is the data type of every column and how many null values means. Obviously, it is not telling you how many null values, it is telling you non-null values. You can just calculate it very easily in the next step, which we are going to do. So over here, you can see the memory usage is this much. I would recommend you go and change the column, some of the columns type, instead of float 64 to float 32, and then run this info thing all over again on this data set, and you're going to be able to see that memory usage would go down. So this is 272 plus MB. That means it is more than 272 MB it is using right now. But if you convert all these float 64 into float 32, this size is going to go down. So so this is what we have. And here you can see how many variables are float, 9 of them. How many variables are integer, 4 of them. And how many object variable, 21. Object variable are the ones you should be looking at, because these are technically your categorical variables, most probably. So which means you have 21 categorical variables. That means encoding will come into play here. So encoding is basically, keep one thing in mind. Why do we need encoding? So the simple answer is machine do not understand anything other than numbers. Machines only understand numbers, which means anything written in string form or in alphabet form, or its type is object. Object means it is not able to determine what kind of a type it is. Is it string or whatever, or is it mixed type? It sometimes it has alphabet, sometimes if it has numbers together or something like that, which means it cannot determine it. So if it cannot determine it, then it just assigns an object. So one way to save your memory is another thing. If you know this particular column type is integer and pandas is not able to determine it, when you are reading the file, you basically can determine it, because remember I showed you here that you can tell which particular columns should have what particular data type, so you can assign it. So over here it's kind of like a lot of things, but here you can start reading the descriptions. All of these things are being described here, what exactly they does. File path picks up the file. This is the separator, the delimiter, or string default or something like that. This is the delimiter, my bad. This is the header, whether you want it or infer it or whatever. Names, index column, use columns, squeeze columns, prefix, or data type. So this data type parameter, you can determine which column should have what kind of data type. So you can determine that. And that's gonna help reading or reducing the memory. So right now you don't need to worry about memory. Okay, so that is one talk we have already done. So let's move on to the next step. So next step is, so this description was for the previous data set. So you can update it, means I'm just summarizing whatever I have. And that is a good practice. So over here, as you can see, there are 3 object columns. So, but in our case, there are 21 object columns. So I would just update it. Keep one thing in mind, writing good descriptions in your notebooks. What is the advantage of notebooks instead of PyCharm or those IDEs? Because you can write in Markdown and you can write descriptions. You can write so many different things in HTML or whatever. So that is a good way to summarize, because you don't want to take a look at the data all over again. You just write the summary and just read the summary and use the summary for the next stages. So as you can see, there are 21 object columns and I can name them. So this is also one thing in Markdown. If I want, you can see over here, this is a bold kind of like thing. And how it is bold, I'm putting it inside 2 double stars. If you put it in 2 double stars, it would be this. If I put it in 3 double stars, it's going to be underlining it as well. So which means if I do it here, hopefully. So is it doing it? So seems like on GitHub it is different, because Google Colab uses a different Markdown and GitHub uses a different Markdown. So there are differences, but it means if you render it on GitHub, it will be giving you an underlined one. But these are things you can use it. If you want to highlight something, for example, if I want to highlight these values, I can just put this and I can just put this. You can see now this one is highlighted over here. Okay, so like a code, if you're writing a code, example code or something, and you want to highlight it, you can do that. So Markdown is also essential. So right now, if you don't know Markdown, forget about it. For now, just focus on Pandas and Python. Now, here I have a code for figuring out null columns. I can describe it for you and let's understand it. So first of all, this variable is named train. Since I'm using train all over again, let's go back and change this variable name to train. This is going to save us a lot of trouble. So I'm going to call it train. And I'm going to read it. Okay. So I'm going to call it train. I'm going to call it train. It. Then I'm going to call it train and I'm going to read it. And then if I run this, it's going to calculate the percentage null values of every column. Here we go, which means first row class column has 29.14% values missing. How many total in numbers? It would be this many. First row number, how many percentage? It is very small. Only 2 values are missing. Second row class is missing 41.9. That means you can note down this column is of something you need to be taking care of while fixing the missing values. This column is an important one. This one, I can just drop these 2 values and I'm good, because 2 values out of 1 million, that's fine. So this is 1%. This one is still not that big. Yes, it is about 100 and or in fact 10,000, a lot of values. So we have to be careful about it. So this one is pretty small, 29, I can do that, I delete it. 269, I can delete it. 111, I can delete it. This 111, 111, 112, which means I can see this column does not require much kind of like, I can drop these, I can drop this one, I can drop this one, I can drop this one, this one, this one, this one, this one, because these values are almost negligible as compared to the data size we have, which means out of 1 million data set, if only 500 values are can fix 7 or 8 or 9 different columns, I would take that any day. Make sense? So if I have less data, then I have to think about it. But if I have so much very big data, then I don't need to worry about 2 values or 111 values or 269 or 37 values. That's reasonable. Even 1000 values, I would take a look at it, but it is less than 1%. It is 0.11%, which is pretty small. So anything below 1%, we should be able to drop. We still have 99% of the data. That means if dropping 1% can fix majority of the columns, then we are left with few columns to fix. Make sense? So keep one thing in mind. What is a good number of dropping values? Every data is different, and depending on what kind of variable is missing the values or things like that, based on that, you determine whether it is a good idea to drop the values or not. There is no hard and fast percentage that you should stick with always. Okay, never ever think about it that always below 1%, drop it. If you just have 100 values, you just drop one of it, now you have 99 values. That is more valuable, dropping one value over there as compared to when you have 1 million values and you are dropping 1%, which means that is just 1,000 values, I think, if I'm right. I don't know. So or 10,000 or whatever. So 10,000 is a big number. So which means over here you can see this is what. Now, yes, it is good. I can see that and I can write about it, which means I can summarize my observation. I can write that these columns needs to be fixed, which means they are important columns which have more than 1%, and those columns which have less than 1%, we can just drop those missing values and we just fix those variables. So I can highlight over here, I can write in the markdown that this column needs to be fixed, and this column needs to be dropped. We can drop the missing values and it is already fixed. Okay, so I'm not changing it. I'm not writing the markdown for now. I will leave that for you. So what you can do over here is I can extract the list, and so these are the null columns. So I'm just extracting the null columns because if I don't do that, then missing no is what I want to see. So I want to visualize the missing values. Where exactly values are missing in the data set, I want to see that. And this missing no library has a limitation. If you have more columns than 60, then it starts throwing you some errors because it starts reducing or getting rid of some of the columns above 60. Since we don't have more than 60 columns, we should be able to do that, which means if I just use train instead of null columns, I would just use train. I should be able to get the result. So it is generating, creating. Okay, so PLT is not defined, which means I did not imported my matplotlib. So let's import this matplotlib. So I'm importing matplotlib. Sometimes you would see this thing with matplotlib. What does this do? In the notebooks, Jupyter notebooks or Colab notebooks, you don't need that. But when you are using PyCharm or something, you need that, because this tells it that you need the output in the line. Otherwise, it does not give you. But these notebooks already have kind of like figured it out that it should be in the line. Even if you don't mention it, you will get the results anyways. So I will show you with it and I will show you without it so that you can see what exactly is happening. Let me import it, the matplotlib library as PLT. And now let's define the missing node. So, okay, you can see where the values are missing. So this column is of much importance. This column is of much importance. This column, I can fix it. This column, I can fix it still, or maybe I can still give it a bit more value. So technically you can see in all those columns, these two columns is what require our attention. Rest of the others are not missing a lot. So this is a good visualization to see how many missing values. The white lines are showing you where exactly they are missing. For example, and I cannot see the relationship between the missing values because sometimes, for example, like this is not the case. Let's say they were recording wind direction and they are using same tool to determine 3 different things or 3 different parameters. If that tool was not working one day, which means that particular day would have 3 missing values instead of 1. So you can figure out relationship between certain columns, certain parameters, visualizing this missing no value. Because this way, if you see the values of 2, 3, 4 different columns are missing at exactly same level every single time, which means they are linked together somehow. Find the link and that will help you determine their correlation and so many different things. Maybe in feature engineering part, you can make one feature out of those 4 together. Okay, so that is what this visualization helps you determine. Sounds good. So what am I doing? So I'm not showing you how to code. I'm showing you how to understand these things, because you can copy paste. You all means I will provide you this notebook and you will have this template with you. So just go, what you have to do is just change the data set. Whenever you come across a new data set, you change the data set here and then start using everything and start updating your description. So these notes and everything, start updating it based on your new data set. And that is what you all have to do. And you would have a good starting or starter file for any project whatsoever. Okay, no matter which project you are doing, as long as you have a tabular data, CSV file or Parquet file or whatever, the only difference with Parquet file would be to just, instead of read_CSV, you just write Parquet over here and it should do the same job. So since I didn't have to, I just use the CSV one. So now I can write, yes, Dania.
I have a question regarding the percentage of null values.
Mhm.
I would like to know if there is a special threshold, if we
Nope.
can say that.
Nope. There is
So it
never
depends on the project.
It is always determined based on the project. Yeah. What size
Okay.
data you have, which variable we are talking about. So it is never ever, you can, means there's no number that I can tell you which you can use for every project. So for some projects, it would matter. Means for some projects, losing more data, you are good with that. But in some projects, losing that much data may be costly. So we have to be very careful about that. So there is no threshold value. Yeah. It's always your good judgment. Means it's always based on who is doing it. Means it's my better judgment, my experience. Based on my experience, I would see that let's drop it, because First attempt is always using the simplest thing, dropping all the null values, dropping everything, and throwing it into the model and see what the model is giving you. We call it a naive model. Naive model means a model which you have to beat when you pre-process correct way and you encode a correct way. So you need to identify what. So the first model is usually the naive model, we call it. Naive model is the one which requires the least amount of pre-processing, EDA, and everything, because when you are deploying your model and everything, the more pre-processing steps you have, that means more chances of error a customer can come across, which means the less number of steps in the pipeline you have, that means a better model and faster model. So that is where the first model, when we get to the deployment phase, we will talk about the naive model. Naive model is the one which is generated using the simplest possible data pre-processing steps that you can imagine. Sounds good?
So you mean the pre-processing step should be as short as possible?
For the first naive model. So right now we are breaking it down into sections and we will do it. But in reality, if I'm getting this data, what I'm going to do is I will pick up the data, get rid of all the null values, throw it in my model and see what results I'm getting. That means now I know what kind of results I have to beat when I do the real pre-processing. When I introduced some encoding techniques, some imputation techniques, when I fix those, instead of dropping all those null values, if I fix those values, can I have a better advantage? So which means I have something to compare. That is the model, we call it a naive model, the one which requires the least amount of pre-processing or the simplest model possible. Yes, Ovis?
Sir,
Mm-hmm.
which encoding technique should be used for a categorical variable with large number of classes? Like I was facing a variable in my data that has almost I think 200 or 300 different kind of classes, and you advised me not to use ordinal encoder for that.
Mm-hmm.
So I browsed the internet and I couldn't find a satisfactory answer for that. So
Okay, so let's talk about it. So the answer to that is you have to see. First of all, look at those 200 categories, because sometimes what happens is you can see 200 categories, but technically there are some spelling mistakes which can create same category as 2 times or multiple times. Can you put several categories together or not? Means if you can put several categories, so you have to go deep dive in those individual categories, look what kind of information those categories are giving. If 10 of those categories are exactly the same thing, just the name of them is being spelled wrong, that means it introduced 10 different categories. Technically, it is just one. So first thing you start with, are there any spelling mistakes which are creating more categories or not? That is the first thing you would do. So this way you can reduce the categories, and you keep on doing that. And then there are so many. Ordinal technique, I would not recommend it, even if you're using tree or something. So I would recommend explore about cat boost technique. Okay, so what cat boost does is cat boost give partial order, means it not just assign 1 or 2, it can assign 1.2, 1.3 encoding. And it is a boosting technique, a tree-based method, which means a perfect method, means it takes care of the importance and everything. Based on that, it assigns those numbers. Instead of you assigning ordinal data, cat boost is gonna be figuring out the importance using the tree methods, and then giving it a particular number based on its importance. And that would be a good way to do it. means this. I haven't taken a look at those categories and everything. I cannot go in more detail, but this would be my strategy. First, I will see if I can reduce the categories somehow by taking a look at those categories, whether they are the same thing, spelled differently, or maybe labeled differently or something. If I can merge them together and reduce the number of category size, that would be amazing. But if not, then I would go to the cat boosting.
Okay, sir.
Cat boosting is not just one. There are so many other, but cat boosting is my go-to because it uses the tree method, and I trust the tree method. It assigns the importance, the impurity, and those things. Which means, and cat boosting is something which is winning competitions. So, which means I know that it has won several competitions on Kaggle and everything. So cat boosting would be one thing you can use.
Okay, sir. I will do my research on cat boosting.
Yes, I would
Thank
recommend you search on Kaggle, cat boosting imputation, or not imputation, cat boosting encoding. So there are so many very good notebooks you will find over there, and pick up their code and apply it on your thing and see what kind of results you are getting.
Okay, sir. Okay, sir. Thank you.
Yeah. And we will get to that part, so don't worry about it. For now, this is my idea. Just do some research, see if you can get something out of it or not. Yes, Kevin.
Yeah, hi. Just go back to the ParQ files. When I tried to import the accident data ParQ file, I put in the chat there. I got that Unicode 8 error. Now I did try and research that. I couldn't find anywhere to actually fix that, so I ended up just using the CSV file.
So what error did you get?
It's Unicode. It's in the chat. Unicode decode error. Can't
let me see.
decide.
Oh, sorry, my bad. I did not see in the chat. So let's start from here. Where did I miss? Okay, accident df, why says non-null if it has null values? So it is just telling you, Joel, when you do .info and it tells you how many non-null values it has, which means if that number is not equal to the total rows, there are some null values. So it just tells you how many values are there. It does not tell you how many values are missing. So non-null values means they have some values. So then, yes, Oves, thank you for explaining that. Float 64 using 64 bits or 8 bytes. Yes, thank you for clearing that up. Non-null means that the count, that's good. Thank you so much. We also use to get the count of missing values in each column. Yes, we can do that, Vezan. So it's just I created. It means I never bothered to update it. It is working fine for me, so I just stick with that. And technically, I did not write it. I just copy pasted it from one of the Stack Overflow questions. So, so large numbers cannot take float 32 because they cannot fit in 32 bits. Absolutely, that's right. Thank you, Wes, for thank you for sharing this link. Please check out how to reduce memory uses in Python pandas. Which is your partition limit? I've already explained that. Everyone determine it, since Oves has already done more research on this data than me, so I would stick with his recommendation 3 to 5%, because I haven't taken a look at data as much as he did. So I would recommend with the 3%, so that's fine, 3 to 5%. Sometimes to see what we get in the end. Absolutely, Fariha, we always do hidden trial, and that is what we will be doing. The number of data pipelines we will be creating, you will see there will be a lot. So you can try so many different imputation techniques, encoding techniques, and every technique is gonna give you different results at the end. You can do several different feature selection techniques, like you can use recursive feature elimination. You can use forward elimination method, or you can use light GBM or random forest or whatever tree. So, okay, and anyone means I'm kind of like giving this workshop in as much detail as possible. Yes, it is taking time, and if you're good to go. If you cannot attend the remaining of the session, don't worry, because we would be uploading it on YouTube anyways. Okay, and you can ask me questions in the next session. So just gather. I would always recommend keep a notebook and keep writing your questions. And in the next workshop, just ask me. If you just put it on Slack, yes, I can answer on the Slack, but I won't be able to explain better way. Means I can show you examples here in the meeting. On Slack, I cannot. So I would recommend just write down your questions and bring it to the next session. And in the next session, I can answer all those questions. So that would be a good strategy to do. Yes, Dunya?
First, I would like to know if we can have access to this template.
Yes, I will upload it on GitHub.
Slack?
You would have.
Okay.
I would upload it on GitHub. I will share the link with you.
Second, okay.
Yeah. So
second, I would like to know if XGBoost is good for XGBoost. Is it good for future selection?
Yes, XGBoost, so any tree method, you can use it for feature selection, because all the tree methods, they do feature selection in the background automatically. So which means you can use any tree method for feature selection.
Okay.
Yeah. So means anybody, you can see what kind of a session this is. I'm doing means kind of like code along with you. Technically, I'm not typing any code. I'm just using my template, and I can give you template and you don't need to type the code whatsoever, because what Hassan previously said, majority of it is about what to do, and coding, you can just get it from Stack Overflow. So which means if you think that you are getting value from this meeting, I would recommend you attend it. If not, then just watch the YouTube video, and means because I would be uploading it on YouTube. Sounds good, Vajia? If you means it's up to you. It is not mandatory or things like that. It's up to you. If you have any questions, join in. It's kind of like you can say a tutorial, and more kind of like you can say it is office hours. You can ask me questions. So okay, Joel, let's talk about this. Let me share my screen. Let's talk about. So when you look at this particular graph, yes, I can see some very important things. I can see this column and this column needs to be fixed because there are a lot of missing values. The first thing, what I can do in my most simplest possible scenario or naive model, I would just get rid of all the missing values. And then I would kind of like put it in my model and see what kind of results. That means that is the result I need to beat technically. And then I will start introducing a encoding technique, imputation technique, and then I will throw it in my models and see, did I improve my results or not? If I did, that means then I will go back and I will try different techniques, and then I will throw it in my models and I will see, did I improve my results or not? If I did, then I would start making it better and better and better until I cannot get more better. So that is the whole sequence. When you are doing these projects or something, that is the whole sequence. In terms of Kaggle, yes, Kaggle is competition. That's where you have to keep on improving 0.1, 0.2, and that can make a big difference, make you jump several different places. But in real life, improving 0.1 or 0.2 and wasting time on that is not, nobody does that. 70% accuracy, a lot of people would take that model happily, or a lot of companies would take that model happily if you have 70% accuracy instead of 90% accuracy. So why? Because they want to deploy it and they want to see, and they can keep on upgrading it in the background, and they just want to deploy faster. So once you get a reasonable kind of like model prediction, you deploy it, and then you keep on making upgrades on that later. So competitions are different, real life is different. Okay. Now, what kind of information I'm getting from here is this column and this column are the two most important columns I need to look into for the imputation part. This column also has more missing values as compared to others. This one, and this one, I can just delete those rows and I should be good. Okay. And if this one is less than 3%, as always, and Kevin said that 3% should be good for this data set, you stick with that. 3% is fine because we have a lot of data points for now. But if you want to try some imputation technique, do it. So that is the information I'm getting from this graph. Now, you can update the over here what kind of information you got. So this template is pretty good because you are taking notes as well, because you don't want to go and read all those things, and you sometimes forget, because if you're doing several different projects, multitasking and everything, you will forget what you did for this, and then you would go back and get those insights again. Whatever insights you got, write them down. Then you come here and then you figure out the description. Description tells you all those things: the count, the mean value, the standard deviation, minimum. This tells you something very important. What kind of importance it can give you? Let's try it. So what I'm going to do is I'm going to do this. So I don't need to do this. This technically converted into means a transposed form. Transpose means the X came on Y and Y came on X, because for me, I find it easier to read it like this. Okay. But if you want to get rid of this part, Control X, and you do it, it's going to give you something like this. So these are the count and things like that. And you can see now I need to drag back and forth, but I don't like that. So that is the reason why what I do is I basically just transpose it and change the style, which means it's going to show me everything in my visible screen. So now I have everything on my visible screen. I don't need to drag here and there. So you can see these are the counts, and keep one thing in mind. When you use describe, it only displays you numerical variables. It does not display you the categorical. In order to show the categorical, you need to put in another parameter inside it. What parameter it is, we can go and search about it. So I would write Python describe function. So this is data frame and this is describe function for pandas. And now you can see this one is percentiles. Include, none is basically exclude. What you want to include, what you want to exclude, you can tell it, which means if you want to include the categorical variable, you can mention it here. So for example, like include all, which means I want to include all the categorical and all the non-categorical variables whatsoever, which means then I would be able to do that. But it's better because their description would be a bit different. So what I can do is I can show you how to do it. First, see what is the difference. So what I'm going to do is I will copy this and I will go here and I would write include is equals to all. So when I do that, so you can see now I have everything. Now, some of the categorical variables, you will not be able to figure out the mean value. You will not be able to figure out the standard deviation value, but it would be able to tell you the frequency and it would be able to tell you unique values. So those are specific to those things. So that is the reason why it's better to use the description for numerical values separately and non-numerical values or categorical values separately. So I'm going to delete this for now and I'm going to use it separately. So just delete it, and this is for my numerical variables. So now how this is important. So this count we have already previously seen, so I don't care about it. The mean value is something you need to take a look at. first road number, second road number. Now, what exactly their description is, you can find it in the glossary that Rich shared with you. And based on that, you can determine, is this mean value reasonable or not? Is this standard deviation reasonable or not? So are these values reasonable or not? For example, if I had a year column, so this is my year column. What is the minimum value? 2005. What is my 25 percentile? 2006, then 2007, 2009, and 2010. Which means one important thing that you can see over here. What if my minimum value was 0? That means there are some 0 values in the year column which are not null, but they are not realistic, which means I need to fix them. Even though we don't have that issue here, but still. Now, number of casualties, we have 1, and you can see over here, 1 is repeated this many times, and the maximum is 62, which means my minimum is 1, my 25 percentile is 1, my 50 percentile is 1, and 75 percentile is 1, and then the maximum is 68, which means there are majority of the values in this particular column which are equals to 1, and there are very few which are 68. So technically, I can convert this column into categorical, right? Because instead of using those 90,000 or 900,000 times, and only few times I have to use 68, it's better to just convert it into a one-hot encoding thing, right? Make sense? So this kind of information you can gather. So if you look at the count minimum max, so which one is odd one? So this one looks good. Standard deviation 52. So you can see the minimum value 25, 50, and 75% and 60, and you can see the mean. Is it reasonable or not? If it is not, that means some of the values are way more than the other one. So most probably that column can be treated as a categorical column, because this way I don't need big numbers, because 1 and 68 means if I put it in my model is going to assume whatever row has 68 number in that particular row for that particular column, which means very much importance, and 1 means very less importance. But instead of just using one-hot encoding, 1 and 0 can tell me that, oh, it is either this or that. For example, what kind of this? Let's read it. Look at this particular pedestrian crossing human control. My mean and standard deviation. Minimum value is 0, 25, 50, and 75 is 0. And there are very few values. Maximum is 2, which means there are very few values which are 2, rest of them are 0. Which means I can also treat it as a categorical column. Make sense? Why categorical? Everybody is getting that point? Any questions about it? And likewise, this particular column as well. So these columns, this one, even this one, and this one. These are some special columns, and we have to think about it. Do they need any kind of because these number does not make sense technically. This 1 technically means 1 casualty, and 68 means 68 casualties. There's nothing in between. Maybe there will be some values, but if those values are very few, now that's where we need to look at how many unique values you have. So you can find unique values of certain things. Means you can find the duplicate values. So first thing I'm going to do is I will look at the duplicate values. So how many duplicate values do we have? Do we have any duplicate value? Oh, we have 6 duplicate values, which means I need to drop those 6 duplicates. Okay. Then the next thing I need to do is I need to figure out how many unique values 1 we have, how many 68 we have, and things like that. And what I'm going to do, I'm going to run this thing and it's going to tell me that. So you figure out. In Scotland, you got only two unique values, which means if you have just 2 unique values, which means it should not be a numerical variable. It should be a categorical variable. And I can replace it with 1 column where whenever one of the value is 1 and one of the value is 68, instead of 1 and 68, I can just use 1 and 0. And this way, I just reduce two columns, one column into a simplistic column, means the numbers are not big. Remember, machine learning models does not like if the numbers are big. You need to normalize, standardize, which means this will save you those steps. Over here, accident severity, there are 3, which means this should be a categorical column. It means I can just convert it into 3 categories. Did police officer attend or something like that? Means you can see these values should be fine. These should be fine. These should be fine. So this kind of information gives you that idea whether you need to convert the data type of certain columns, and this way you can kind of like reduce the or compact or summarize the information well. Now, for example, here I'm creating a data frame with only the null columns. You can do that. So over here, I did not do this. Let's do this. So this way, I will only be able to get the null columns. So let's find the null columns. So this is my null column. So these are only the kind of like it only contains. So I'm just looking at the columns which have null values. The rest of the others, I don't want to touch them. Okay, so you can take a look, you can keep them separate, and you can apply several different things on it, and you can do further exploration. So visual exploration, yes, you can do that. Now this is a poor way to do it, and over here you can use toString, and it's gonna print out pretty well, most probably. Let's do it. Now in category, since I need to update my categorical feature, which means I cannot run it as it is. I need to determine my categorical features over here. I did get the null underscore columns. So yep, let's do null underscore columns. Okay, so train underscore cat and train. So I need to determine the names of the columns which are categorical. So once I do that, then rest of it, I can kind of like figure out. So numerical columns is pretty select data type. So let's find select underscore data type. So I'm going to search it on here. So select data types. If I can include, exclude a selection of data types of strings to be included, exclude. At least once of these parameters must be supplied. Sounds good. So let's take a look at example. Data frame is this. Select data type, include bool, include object. So I would just use object. So here I can use the same thing. Or over here, train.select data type, and I can do categorical or object. So I should be able to do categorical. So category. So let's convert it into category. Let's do it. Okay, we got it. So I'm printing out the train underscore cat head and train underscore num head, which means what I did is I basically divided my data frame into categorical separately and numerical separately. I'm just playing around with that right now. You don't need to do that. I'm just doing it separately so that I can take a look at those categorical variables altogether, numerical variables altogether. So it's kind of like I'm just sorting for now for me. Okay, it is not required process. It is just for me. I just want to go deep dive in the categorical variable, because when I would be doing visualizations and everything, I want to do or write a function which can do everything for the categorical variable, which means if I have separated them, then I don't need to type in train or something, means that this column I need, or this column I don't need. So now I have separated them, and this would make my life easier when I want to do the visualization step. Okay, so and then we can do imputation and encoding and everything whatnot. I think for now, for today, I think it's almost 2 hours now. I think let's finish it today. I will continue from this, means I will record a visualization video and everything, doing several different steps and showing you simple imputation techniques and KNN imputation technique or things like that in our next session. So we will talk about that. Most probably I will record a video and upload it and you can watch it on YouTube. And in the next session, we can talk about it, or I can do it in the next session. Okay, if anybody has any questions whatsoever for what we have done so far, please go ahead and ask me. Yes, Narendra, please.
Just good question. So I just want to know, so since we are having million records, right, how we can do imputation, KNN imputation technique for various values of n to find the optimal.
How we can do it? We can do it. Yes, it will take more time, but it is a good kind of like, you can say, it is the best technique. So I will explain what KNN imputation is, and yes, it will take time, and I will leave it up to you whether you want to use it or wait a minute. So whether you want to use it or where did it go? So whether you want to use it or not, yes, depending on what kind of processing power you are using or something, yes, KNN imputation is going to take time. What I'm going to do next time is I will break down the mathematics behind what exactly happens in KNN imputation. And this will give you a good intuition why KNN is a good imputation technique. So because KNN finds the nearest neighbors, and based on that, it puts the value. Instead of using the mean and mode value, it figures out, so we have million data sets. Out of those million rows, it's going to compare that particular row which has a missing value, and it's going to compare, so it's going to break down or find the distance of that row with all the other rows. The rows which are closest, the K number tells you how many closest and nearest neighbor you want to look at. If I put my K value equals 10, what it's going to do is it's going to look to the closest 10 nearest neighbors and see what value it has for that missing values in your row. And then it's going to either average it or pick the most frequent one out of those nearest neighbor or something you can determine. And then it's going to put that, which means it is more, computationally expensive, but it is more reliable. Instead of just using mean or mode imputation, it is more reliable. And I'm going to give you some sneak peek into some other imputation techniques as well, like some transformers or something. So we will talk about it, simple basic transformers. So we will talk about it. So does that answer your question?
Yeah, yes.
Okay, so any other one? Yes, Dunya, please go ahead.
So I have a question about Kaggle, if it's possible.
Sorry.
About Kaggle.
Oh, yes, sure.
So it's not about the. So I've noticed a huge amount of criticism towards Kaggle competitions, and I would like to know what are the real benefits that we can gain from this type of competitions, because people are pretending that it's a waste of time, or it's not like real life projects.
No, it is not waste of time. So Kaggle is, so keep one thing in mind. Kaggle is different than a real life data project. Why? Because in the real life data project, I told you that it does not matter whether your result is 0.90 or 0.91. Over there, people are competing for first position or gold or silver medals or something like that. And that's where you are kind of like maybe ensembling your model in a way that you improve just 0.1. In real life, that 0.1 does not matter. So yes, Kaggle is a competition kind of a thing, and you learn a lot. So on Kaggle, if anybody is saying Kaggle is a waste of time, it is not a waste of time. Kaggle is kind of like makes you do troubleshooting. How to improve means which techniques, because when you apply so many different data pipelines, because it's all about creating 10 different data pipeline. If I have uploaded 10 different versions of my model and every model is improving, which means I was able to figure out, do some tweaking. And this is where the troubleshooting comes into play. And using that troubleshooting, you are becoming a champion of those techniques that you are using, because now you know which technique to use in which particular scenario. And that's where Kaggle excel. And a lot of Kaggle, I would never discard it. If you are a Kaggle expert, or if you are means Kaggle master or something, you have gotten either a bronze medal in any competition, that tells something about you, which means you know how to troubleshoot, how to improve models, which means how to play with different techniques and improve your results, which means because you cannot do that just by copy pasting somebody else's code, because anybody who is sharing the code, they never shared the code which got the best results. They just shared the one which they improved on maybe. So which means if you want to improve on it, you need to apply your understanding or additions onto it so that you can improve on it. So I would never discard Kaggle. Kaggle is amazing platform, and yes, it is different than real life project, but you learn a lot with it. Yes. So yes, Mukesh.
Hello, Salman. First of all, thank you for wonderful session. Sir, I have the question regarding the conversion of numerical feature to categorical feature. So I will take one example where the minimum value was 1, 25 percentile, 50%, 70% percentile was 1, and the maximum value was 68. So if we have values, very few values other than 1, so almost that feature is having similar values. So can we drop that feature?
No, we cannot drop that feature. That's where I'm saying, yes, that feature, because right now we cannot tell. We haven't done any correlation. We haven't done any univariate analysis, multivariate analysis. Maybe that feature is important in determining or for our target variable. So we cannot drop it. But one thing I can keep in mind is using number 1, 68 or 58. Let's say it has 3 values, let's say. So if it has, so look at this number of casualties. Let's see how many values number of casualties have. So let's find number of casualties. Do we see number of casualties here? In this one, you can see how many different values it has.
41.
Which means, yes, majority of the values are 1, but some of the values are more than 1. So which means about 40 different values are there except 1. So 1 is the most abundant one, and the rest of the other 40 are not that abundant. So yes, it is giving me, means I'm just taking a sneak peek and I'm thinking about it. What can I do? And since I didn't know how many values are different than 1, that's why I figured out these unique values. And here I can see that I was thinking about converting into categorical, and that's not a good idea because I have 41 different values. If I had only 1 or 2 or 3 different values, I would have converted into categorical. But now, no, I should leave it as it is. Make sense?
So if I further investigate and find out that the almost 99-98% values are 1, and rest 2% are others. So in that case, can we drop?
Still,
because there are just 2%.
So what I'm going to do is I will be converting into all categorical anyways, and I will be using ordinal encoding instead of whatever encoding. So technically, right now you see the values. There are 41 different values. So some values have 68, some value has 28 or something. So based on those numbers, I can just convert them into ordinal values instead of using 68 as a one of the number or something. I can just do that because this way my model is not gonna freak out because if the differences between, if you have some values which are technically, here you can see Number of casualties is technically telling you categories, means one casualty, 18 casualties, 50 casualties, 68 casualties, or something like that, which means you can just convert it into ordinal, that order one. If you are getting number one, that means just one casualty. Two means 20 casualties. Three means 50 casualties. Four means 68. Instead of using those big numbers, because it's kind of like your equation y equals mxb. The bigger number of x you are going to do, that means your machine needs to learn it way more, means use more computation power in order to learn it well, if you just convert the numbers into reasonable numbers. So even if it is 2%, I would still not drop it.
Okay, got it.
Yes, I will do the EDA part and everything. Until then, I will not drop it. So until then, I will determine whether it is good to drop or not, because I need to look at the correlation. I need to look at the univariate analysis, multivariate analysis. Then I can do hypothesis testing, whether it is good to drop it or something like that, whether it is of importance or not. So there are a lot of things we can do. So which we will do in next few sessions.
Thank you.
Okay. So it's not about whether the value is one or other than one. It is about the total. Yes, always. Thank you. So, okay. Thank you, Joel. You like that they provide any kind of learning resource. So yes, Kaggle provides. Kaggle have free courses on it. Means we can explore it. You can see Kaggle overview. So you can see they have these learn. So these are a few courses: Intro to Programming, Python. It has a lot of courses on it here. There are several guides over here complete. You can take a look at it. And I would recommend, if you're a beginner, take this Intro to Programming and Python course and Intro to Machine Learning course. Means right now we are not into machine learning yet, which means I would recommend take a course on pandas, data visualization, feature engineering, because this is what we're going to do, and pandas is what we are using right now. So I would recommend take this course, and if you're a beginner, it would take you so it's kind of like not much time, maybe 2 hours you will be able to finish it. So this one 2 hours, and you will get a certificate. You can share it on LinkedIn and brag about it on LinkedIn. Okay, I'm a big believer of bragging about it on LinkedIn. So 2 months ago, I had 490 connections on LinkedIn. And after 2 months, you can check out, I have about 3,800 connections. The only thing I started doing is bragging about what I'm doing and sharing whatever I know. So it can make a huge difference. And based on that, I'm getting a lot of different opportunities, like speaking on different events and giving different workshops in different universities. And I will be giving a talk or a presentation on a platform, a deep learning meetup, which is organized by a big company, Decide.ai. And the people who are presenting with me, they are from Microsoft. They are founders of their own companies, and their companies are big. And among them, I'm kind of like giving presentation just because of bragging about on the LinkedIn. So I'm telling you, networking is something you need to start working on this journey. Only projects will not help you. So take these courses, publish it on the LinkedIn, and if I get to see your post, I will engage with it. So, and keep one thing in mind, I would recommend all of you to support each other, engage with each other post, because this way your network is also notified that you have liked somebody else's post, which means you are leveraging other people's network as well. If you want to tag me or Rich or Omdena Liverpool or Omdena, do that, because Omdena community is very helpful, and people have been coming from different Omdena groups to like your post, because they want to support Omdena. And since you are part of Omdena, they support you. So I would recommend you use that leverage. This is the advantage we have here. Okay. So almost everyone numbers would be 1, and the rest would be number 2 and 40 after replacing with ordinal to help the model. Yes, Joel, we will talk about it. We will do that in the next session. So don't worry about it. So right now, don't worry about doing this. I will show you how to do it, and then we will see whether it is a good idea or not. So far, what I'm doing is based on my judgment, based on my experience. So because there is no hard and fast rule on any data, every data is different. Whatever you do is based on your judgment. And those judgments keep on getting better and better as you keep on doing more and more projects. Sounds good? So did I miss anybody's question? If not, then let's finish it up, finish this session up. Everyone's good? Okay, if everyone's good, then thank you so much, everyone. If anybody missed it, I will put it on Google, on YouTube, and share the link on Slack, and have a good one. Bye-bye.